Hi, welcome to this new video. I'm Sergio, I'm a computer vision consultant, developer, and course instructor. I'm the founder of PySource, where we build computer vision solutions to help companies improve their process efficiency, reliability, and scalability. Today I'm making a totally new type of video where I'm going to reply to your questions. 2 weeks ago, I sent an email saying, ask me any questions about computer vision, and I got a lot of interesting questions, whether you are a researcher, a student, a company owner, and so on. I'm going to reply to the questions right now. If you like this video, please put a comment down below. Let me know that you have interest so I know that I can bring more videos like this. Like this video and subscribe to the channel. Let's now get into the questions. Hi Sergio, thank you for this opportunity. I'm currently working on an issue in the automotive industry. We have a product which is quite big, 30 by 20 centimeter, and we have a camera on top. Currently, the camera with classic CV is making several stops at the right position and taking a picture. This takes very long time. My idea was, if we can replace this by computer vision with deep learning, now I have a big resolution, but small parts that need to be analyzed and identify if okay or not okay. What do you think about this issue? Is it solvable? Let me break down this problem for you also that we can understand better this one. For me, it's not very clear where now is the camera. It's camera on top, where I'm imagining this could be a manufacturing company where there's a camera on top which sees the product. That's how I'm imagining this. So let's now draw this, which is a conveyor belt. And here there is the product like this. So we have many products passing on the conveyor belt with size 30 by 20 centimeter, and the camera is on top. So there are several stops that this needs to make because it's using computer vision with the DALI, called this classic computer vision. What is classic computer vision in this case? Imagine classic computer vision to be very old algorithms, because then it talks about what if we use deep learning. So it's very old image processing algorithms that don't have any artificial intelligence. For example, edge detection, color detection, some filters that you can do with images, and so on, which they have no real intelligence. So it's possible to use them to identify some defects in a control light environment. It is very important. Control light environment, so to find some edges or some different change in the intensity of color and so on, but it's not possible to have like some reliability with them, especially if you want also some speed. So how can we solve this problem? So let's start by asking the question, is it possible to solve this problem? Absolutely yes. I hope that this is like the scenario or similar scenario, but even if it's a different scenarios and it's not a manufacturing company, the procedure is similar. With computer vision and deep learning, we can solve this. There is no need for the conveyor to make several stops, because with the camera, we can put a high resolution camera. Even if the conveyor is going very fast, we can capture that with OpenCV and deep learning. So let's now go more into some technical aspects. Imagine that the camera on top has such view like this, where we see the product from the top. So there will be the product, let's say that this is the conveyor belt, the products are passing, and so on. When the products are passing with the camera on top, we can detect them with object detection. So one solution would be object detection. What can we do with object detection? We can extract the picture of this product. So we have this. When the product is passing, we take a picture, and even if it keeps moving, we extract this picture. We can extract picture with high resolution. Then what can we do right here? It depends on the complexity of the task. Of course, we can't get too much into details because also we don't know the details, but it might be a simple classification where product is okay, product is not okay. Simple like that, okay, not okay. That's one way. Or more advanced, we could perform object detection inside this image to find maybe type of defects, where it could be, I don't know, let's say if here we have some scratch, we could find the defects inside the product and so on. So object detection is a must right here, and second, you could use classification for the defects. Second, object classification. It's important to have a good resolution of the camera, industrial camera with high shutter speed, especially if the conveyor belt is moving fast, so that the quality of the image is very clear, and also a good lighting to have as much as reliability for like how we see the product. Hope this answered the questions, but at least it gives an idea of how to approach similar projects, especially if you want to help manufacturing companies or any company that needs to do quality control. Let's now go to second question. Question number 2. How can I get into computer vision? How can I expand upon into more complex projects? I always find using computer vision for specific tasks quite daunting, as there is often less information available for the specific requirements I wish the computer to achieve. So imagine you to be a beginner in computer vision and you have no idea on how to start. And probably most of you, I mean, not most, many of you that are watching the videos have some ideas about computer vision, but you could identify as a beginner. In this case, if you want to get into complex projects, I recommend first always to have a good understanding of the basics. Let me give you some framework for the basics, like let's say some blueprint for the basic. OpenCV is a must. If you want to work with computer vision, OpenCV is a must because OpenCV is the most popular library that you will use for image processing. So you need to understand how to grab the videos from the camera, how to process images or videos in real time, to do all the operations that you will need when working with images, cropping the image, rotating, extracting some part of the image, and so on. This is a must. Then, in order, you can go to object classification, classify what's inside the image, object detection, to detect object detection, to detect objects in the image and surround them with a bounding box, then object segmentation, and a lot of other more complex stuff that we can do with computer vision. Start with the basics, then you can understand later on how to go into more complex stuff. Once you know the basic, you can get a lot of ideas from YouTube videos that you find about computer vision. I put a lot of them about different topics about computer vision. You will find a lot of articles, not only from me, but from many bloggers, developers that release articles about this. So there is a lot, but only after you study the basics. So that's my recommendation to go with this. Also, if you want, there is a course, Computer Vision Blueprint. You can sign up there, where I give you some guidelines to build computer vision projects with OpenCV. Then, number 3, question 3. Is better to use TensorFlow or PyTorch for such project, as advised to use PyTorch again and again? Thank you. So I'm not sure what specific project, but let's talk about TensorFlow and PyTorch. There are 2 deep learning frameworks. One, TensorFlow, is maintained by Google, and PyTorch by Facebook. For me, I will go right away with PyTorch. PyTorch is on top. From my experience, I noticed that PyTorch is better in terms of speed and performance, so even usage of the memory. But also, not only PyTorch is much more popular for all the libraries that we use now with computer vision. So, for example, YOLO mostly runs on PyTorch. Of course, it runs on both of them, but the original repository are mostly in PyTorch. So, if you have to choose between these 2, I would say PyTorch. Then, of course, it depends on many other things. If you are a developer and you want to develop some of this library, you might find pros and cons on each of them. If you want to use the open source algorithms, PyTorch is one where usually you will find them. Question number 4. Hi Sergio, many thanks for your great tutorials on YouTube. I have a question regarding a tutorial on measuring dimension using a Ruko marker. The tutorial you had assumes that the camera for OpenCV is always facing perfectly downwards. So in order to measure an object, we need a perfect top view with no tilting. But what if the user provides an image where the camera is tilted? For example, a square box would result in a trapezoid shape, so the dimension will not be accurate with the existing code. Can you do a tutorial where you revise the code to detect and compensate for the camera being tilted? It could be possible by detecting the Ruko marker pose, but this will be very helpful as a tutorial. Sincerely, Dominic. Okay, I can't do a tutorial, but I can give you guidelines about this problem. Now, let's break the task for, if you don't know what the previous tutorial I made about identify the dimension of the project with a Ruko marker. This is a very requested lately type of projects that I get also from companies to measure dimension of products. And in the video, in this specific video that I made on YouTube, it worked like this. There is a webcam on top, and then right here you can place the object. To understand the dimension of the object, we're going to use what I call an Ruko marker. So let's now see the view as if it was from the webcam. So this is what we see from the webcam. Let's say that there is an object right here. Let's say that there is a pen. How can we measure the size of the pen? If we have only the camera, if we have no reference point, we have no idea what's the dimension and we cannot measure the dimension. Why? Because of the perspective. If the camera is closer, the pen is bigger. If the camera is farther, the pen is smaller. So we can't normally do this. What was the idea on the previous video is to use an Ruko marker. A Ruko marker is nothing more than a marker to give a reference point. So let's say that we have this marker which is recognizing. We know that this is 5 by 5 centimeters. With this we can give a ratio of pixel to centimeter, because we cannot measure the object in centimeters because of the perspective, but we can measure the pixels. So with image processing and OpenCV, we can identify this pen right here, and we can measure the length of this pen. We can say that it could be, let's make it simple, 100 pixels. We don't know what is 100 pixels, so that's why we have the Ruko marker, and with the Ruko marker we make a ratio pixel to centimeters. So if we know that 100 pixels equals 10 centimeters, because of this ratio, then we know the size of the pen. So we know that this pen is 10 centimeters. It's very simple. Now, Dominic here is asking, what if the camera is tilted? If the camera is tilted, so instead of having the camera like we have it here, like this, let's now remove it. We have the camera which is, let's say, is tilted like this. Let's say a little bit tilted like this. Of course, the view will change. We don't see like the square anymore, like we have right here. But when we have a tilted camera on a plane surface, we'll see, let's say that we have a desk, we see the part which is closer, it's bigger, and then it goes something like this. So this trapezoid image that is saying right here. So the object has a different perspective. What to do in this case? Let's say that also here we have the Ruko. Ruko is normally it's normally a square, but here will be, because of the perspective, will look like this. In this case, of course, with pros and cons, because you will lose some precision with this, and so I'm not saying this is the ideal, but it is a way you can solve the problem, is to apply a perspective transform. What is a perspective transform? I did some videos. You can find perspective transformation on my channel, or on the blog, pysource.com. With perspective transform, we can transform an area and change the perspective. So it works like this. We take 4 points from the image, 1, 2, 3, 4. We apply perspective transformation to this point, and then we transform these points into a square. So we will solve somehow the problem easily like this. You apply perspective transform, we get the point, and then OpenCV will transform this into a square again. And so you will see again, even if the area is tilted, you will see everything like it wasn't tilted. Of course, there are pros with this. There are cons, because with perspective transform, if the object is tall, you will have a distortion also of the object, and you are going to lose accuracy. So you can solve this if the camera is a bit tilted, but keep in mind that it will not be perfect. Check perspective transformation to solve this problem. And also, perspective transformation is very important to know. So anyone that wonders what is perspective transformation, if you don't know, if you're working with computer vision, it's necessary. I use this for some recent projects, for some events where we need to associate like the detection from the camera with some real projection, either on the floor or on some screen. So perspective transformation is a must for this. Hope this answered the questions, Dominic, and definitely with that you can easily solve the problem. Question number 5. So let me go with the black again. Okay, question number 5. Hi sir, I have a robot that follows a person through camera using detection by YOLO version 8. My question is, I want to detect just a specific person if there are a lot of them by person identification. I think I need something in real time to specify the target person in the beginning and then update itself with time a new frame that comes of the target. I cannot find video or implementation about it. Thank you for your assistance. This question has somehow already the reply to what you need, because you have a question, but yes, you know what you need. When you want to identify a specific target, so if you are using YOLO V8, let's say that your robot has a camera. So this is the view that you get from the camera. Let's say that you see a few people right here, and these people, let's put a third one, are detected with YOLO version 8. So when you use YOLO, what are you getting? You're getting a bounding box. So you'll say this is a person 1, person 2, person 3, to detect the person. There are 2 ways that you can approach this. If the people are always visible and they don't overlap each other, with object tracking, you can track them, because the person will have always the ID associated if you're using object tracking. And by the way, I released just the previous week a video about this, so this is a perfect timing for you to watch the video about person identification. So check down below on the channel, the latest video before this one is person identification. So one is object tracking to follow the person, or of course you might need to re-identify that. I will just give you some very basic guidelines because I explained everything on the other video, but there are 2 approaches that you can do. If the resolution of the image is quite big and the people are close, you can use facial recognition. So instead of detecting the person, you can detect the face. So let me change this. So let's go with face detection. You can detect the face. By big resolution, I mean that you need to have at least the picture of the face is at least 100 by 100 pixels, so it's reliable. If the resolution of the face is smaller than that, then it starts to be unreliable. So in this case, you should apply person identification, where there is an algorithm for person identification that identifies the person, and it checks if for many features it will take into consideration like the clothing, the height, the weight, the width, and so on. So this is an idea, check more into the previous video about person identification. Now, number 6, and I'm going to be fast with the questions because there are a lot of them, and I will try to reply as many as possible. Hi Sergio, I'm new in computer vision and I work on a project to detect hair changer for barber shop, but none of known library can detect hair area. Do you have any advice? Okay, the problem is you want to detect hair area. So let's say we have a person and we have the hair. You want to detect hair area to detect hair changer. I worked in the past, around 3 years ago, I built some solution for a client which only a part of that was to detect the hair area. At the time, I'm not sure if there is any library now, but I take what you said that there is nothing that you can find anything like that. But at the time, there was nothing that I could find. And what's the solution? The solution is to create a detector to detect the hair area. So there are datasets that you can use, like the Open Images dataset from Google. So search Open Images dataset, where you can download dataset. You have a lot of datasets ready for that, where you have face detection, you might have head detection, and so on. If you can't find anything in that case, you need to create it by yourself. So you need to, based on the project, get the dataset and then make the annotation. So if you want to detect hair area, take thousands of pictures of similar to the one that you will use for the project, and then make the annotation for that so that you can train your own model. And you can do either a segmentation model if you want to segment exactly the hair area. After you segment, you extract the hair. So let's say that these are the hair extracted. After you do the segmentation and you extract the hair area, you can apply some image classification to say like the color, for example. What is the color of the hair? So this is a very general idea, but yes, probably there is nothing like that. You can create your custom detector for this. Let's go to number 7. Hi Sergio, I hope you are doing well. I'm excited for your upcoming computer vision video. Thank you for that. Great to hear this feedback. I've been stuck on something and could really use your help. I'm using YOLO version 6 and YOLO version 9 for object detection. Why using YOLO 6 and YOLO 9? Why? I wonder why not one of them only? And I need to crop photos instead of just resizing them, 640 by 640. After that, I also need to rotate some images from my custom dataset image. Can you explain how can I do this? Thank you so much for considering my question, Guzin. I'm not sure why you want to do this and why you are stuck with cutting the images and because if you cut the image, so let's now explain this. Let's break down the problem. So you're using YOLO version 6 and 9 to detect objects. So let's say that this is an image and you are using this to detect people, like this. So YOLO will give you a bounding box of the person detected. How do they work? This image detector, doesn't matter how big the image is. If you give an image which is full HD, so 1920 by 1080 pixels, they will shrink it to a square of 640 by 640, no matter how big is the image. Of course, you can choose different sizes, you can make it bigger, but in general, it is always a resizing of this. So if you have a big resolution image, 1920 by 180, at the end, it will be shrink to a smaller square like this to perform the detection. Now, you're asking to crop the image instead. Imagine that you want to crop, maybe to proceed on smaller part of the bigger image. So this might be some idea so that you can detect even smaller objects. I'm not sure if this is the question. So there are some algorithms for this which will work in sliding windows so that you can detect on a very big image, you can detect smaller parts of that, so you can detect even very small objects that otherwise wouldn't be possible with a very small size image. Or if you just want to crop the image, you need to take into account that if you have a big image and if you crop the image, then you are losing part of the image. So normally that's not done because you will lose part of the detection. If you want to do this, well, it's very simple. These are very basic operations with OpenCV. There is like the function cv2, I will write it, cv2.crop, something like this. No, sorry, not cv2.crop, but I put some video to do this where like you can crop images with OpenCV. It's very basic. From the big image, it's something like this. Let's say we have the big image, where the big image is, let's say, to make it simple, 1000 by 1000 pixels, and you want only to crop this area. You need to identify point 1 and point 2, then you can extract that area. I will not now get into this because I made a video already about this on how to do the code. It's just one line of code where you extract. It's just simple operation with the array. Regarding the rotate operation, yeah, this is the rotation operation. If you want to rotate object, it's cv2.rotate, and then you identify what type of rotation you want to do. Question number 8. Love the videos. Thank you. I'm glad to hear that. I am a data scientist from MIT. Here is my question. I had an architect ask this. From a video taken walking down the street, can a machine learning model guess the height of buildings or even possibly the measurement of doors and windows? Okay, so let's break down this. You have a video taken from the street and you want to measure the size of doors from a machine learning model. The problem is, like, you have already the video, or is this made to take these measurements? Because to get such measurements for the same things that we discussed earlier, it's not possible because of the perspective. So we need to know the camera that we have, and especially we need more information from what we get in front. So in this case, partially it's possible using special cameras. We need to use either LiDAR cameras, LiDAR or depth cameras. Why LiDAR cameras or depth cameras? Because when we take a video picture of some building, we know how far is the building and we know the distance of each specific point. Knowing the distance of each specific point, we can have a good estimation of what's the size of the object, if, for example, the door, windows, and so on. This is not possible for other type of cameras. I'm imagining that at some point it might exist, I'm not sure, but it's possible to build some library that can predict this by using some references point. For example, if there are objects in the picture and we know the distance of this object, like some pipe, some type of cars, which is a known car, so we know the dimensions of these cars and so on, we get a lot of referencing points. I'm imagining that in the future, deep learning library might give an estimation because it will have a lot of reference points from the environment, so it could somehow predict even not having all the information necessary from the depth camera. So this is my assumption of something that is going to happen in the future, because like the more data the deep learning models get, the more they can predict based on their surroundings. So this is what is probably going to happen in the future. And with this last question right here, I'm going to stop the videos because I'm done with the timer now. I'm sorry, unfortunately, I couldn't answer all the questions. There were many more, but there is no time for that. Please make sure that you stay in touch. You can subscribe later to the channel, or down you can find the course Computer Vision Blueprint, so you can get access to the newsletter. So when there is the next chance to ask questions, you can ask your own question. Again, let me know if there is interest for this video, because I will bring such type of videos only if there is interest and I want to know this. So let me know down below. This is all for this video. See you in the next one.